you kind of explained it to me, I was kind of like wondering like what would be the difference between them? Like which one's like more important?
Okay, from these computer vision NLP, like from these. From
Yeah.
okay, so see, here you have this data science as a bigger picture, and now again you have a different thing, like you have a machine learning, you have a deep learning, you have should I write the full form for them?
No, it's okay. You can.
And then you have NLP. For NLP, you have to natural language processing. If you have heard of ChatGPT, right?
Yeah.
ChatGPT is like most of the time it is your natural language processing because it understands our natural language, right? So that is your use case or your application of this NLP. Okay. Then you have this CV, computer vision. Suppose you want to perform any task like that. If you want to make a project related to hand digit recognition, hand written digit recognition. So if I show you the some results from the web, I have actually made some projects also, but I am not having that project in that in this laptop. So if I show you that this handwritten project, return a recognition, basically what it will do is using neural network. Okay, neural networks are your basically deep learning thing. Okay, so it will recognize your this, right, this thing. You have written this for using your hand, right, on or using this pen, okay, on your desktop, and this machine learning model, this is your neural networks, right? So this will analyze this, and how it does is it will basically take that pixels of image as I told you just a while ago, right? This image is built of your matrices, right?
Yeah.
You see the matrix is created here like white and black. So we will use this data now. Again, we will convert this white pixels in 0 and black pixels in 1. Okay. So this is how we can get an array or a matrix of our image. Okay. So now can use this data and we will try to make some pattern basically, right? Like for 4. Okay. So we will say for if there are certain patterns in our image, like it makes this kind of triangle here at the upper half, right? At the upper half we want some kind of this pattern, and at the bottom half we want just a single line, and also we want at the middle we want a plus symbol like this, right? And this kind of set of instructions this neural network will create on itself. And whenever a new data whenever a new handwritten digit is given to it, it will try to find these patterns. For 4, I have shown you this pattern. For other digit also, so it will take some patterns. And whenever you see some patterns, so it will give you some output. Like this, for this example, it looks something like this, 4. So it will predict that this handwritten digit is 4. Do you got an idea?
Yeah.
Right. So this is how your computer vision, like this was your image, right? Image task. So this will be your computer vision. Like here we have your data set. This will be our data set. Like this will be our input value, this image, and this is our label. Here we are specifying that this input is 2. Can you see this?
Yeah.
Here below this image, this 3 is written. Are you able to see this? below the image,
Yeah.
and below this
Yeah.
7, this 7 is written, right? So we will give this image
Yeah.
to our machine learning model, and we will say that this image represent this 2, that this image is 2, and this image is 4. And now it will learn. Now what it will do is, suppose that it want to learn how 4 looks like. So it will collect all the 4. Like it collect this 4, it collect this 4, it will collect this 4, and it will collect this, every 4 out of this data set. Okay. And now it will try to see some patterns. Are there some patterns? Like what are the common things in all of these 4s? Like this 4, this 4, this, and this. Then it saw that there is something like a big line at the left, right? So these are the rules that are created inside this networks, right? You see here this one network, two network again, right? So these are the basically the set of rules. Whichever, if the image passed them, or if the image satisfy these rules, it will give, if it will give predicts, it will predict you the certain output.
Yeah.
Okay. So this is basically your computer vision task, handwritten digit recognition. Or suppose you can ask to Google like what are the computer vision examples in real life. You may say you have self-driving cars, right? You have facial recognition. Yeah, please say.
Yeah.
Are you saying something?
No. I was.
So you may, whenever you have any doubt, you may please say, okay, so that we can have a discussion about it. So like in your computer vision, we have a facial recognition, we have self-driving cars, we have robotic automation, right? Like you have seen the robots walking on the road, like robots cooking some food, or right. So basically, how a robot is knowing that any particular object is placed at that thing, right? Right. So it basically use the cameras, right? Cameras, and it takes the input, right? And once it got the input, it will analyze in that image or in that video, right? And it will see where the knife is placed. Okay. And then now are using that image input. Now the robot knows that the knife is placed on this exact location, or that can be represented on your using other techniques, right? So once your robot knows that this object is placed at that location or at that point, then it may do perform some other operation, right? That is basically your robotic automation. And it can be also used in your medical anomaly detections. Like you may have x-rays, right? Or you have some reports, like medical reports, right? So your model can also use that and perform some predictions. It can be used in sports performance analysis and manufacturing fault detections, like your computer vision. Okay. If I show you some image, like here, we are detecting whether the cars are in this image. So wherever there will be the car, it will be drawing the box. This here there was a bike, so it is saying that scooter, right? So these are the cars. So yes, so it is basically plotting all the things, right? On the blue area, it has plotted this the road, and this in the green area, this is the trees.
Yeah.
It has also plotted on the red area, this is the car, right?
Yeah.
And on the green, it is saying that this is the street light. So basically, these all data is already fed to this data. Means we have shown how a tree looks like to our model. Okay, our model knows how a road looks like, because we have already shown the road to our model. We have already shown like millions of images of cars to our machine learning model. Now our model knows whenever there will be like this circular thing on the bottom, and whenever there will be some square shape, or like something like this shape, right? And these some like these windows, right? So it will be a car. And if there is a some object with a vertical format and having some, means it will try to see the patterns, right, that it have learned while the training. Okay, we use this term like training a lot in machine learning. Okay, like training is when you give the data to your machine learning model. Okay? And yeah, so hope you got that idea, or want to add something.
No, I understand it.
Computer vision, right? Again, you have your NLP. Now NLP, you can use your NLP for cases like ChatGPT, or you can use for sentiment analysis, or your email filter. Suppose you want to filter out your email, like whether your email is spam or not. Okay,